Hello guys, I'm Alukosha Enoch. Welcome to my math tutorial class on quadratic function. In today's tutorial, I'll be solving quadratic equation using completing the square method. Then second, I'll also teach you how to use transformation method to complete quadratic graph and identify key properties of the graph. So let's get started with the first objective of this tutorial. Okay, if you look at the first question now, I'm completing the square. Solve each of these quadratic equation. X squared minus 8x plus 10 equals to 0. X squared plus 10x minus 9 equals to 0. Because of our time, I'll just solve either of these questions. So let's just go for question 1A. So let me go home and take out pen. Okay, the first step, if you look at the equation you have here, you have x squared minus 8x and plus 10 equals to 0. So the first step is to separate the variable and the constant. So retain the variables on the left hand side and take the constant to the right hand side. So by implication, this will be equals to minus 10. So that is the first step. Then the second step is to take the coefficient of half of the coefficient of x. So the coefficient of x is minus 8. So half of minus 8 is minus 4. So then I have x minus 4, and then you open the bracket and close here, equals to on the right hand side I have minus 10 already there. So then you complete the square. How do you complete the square? You add the square of this value here, so meaning that the square of the half of coefficient of x. So and the square of 4 is 16. So guys, please, you need to take note of this. Irrespective of the operator that is here, whether you have positive or negative, you're going to add the half of the coefficient of x square. Add the square of the half of coefficient of x there. Okay, step 3 now. So I have x minus 4 square equals minus 10 plus now let me import the second question. So the next objective is how to complete the graph of a quadratic function using transformation method, and also to determine the property of such a function graph function. So let's take a look at this first question. Okay, so these questions, so here we have f of x equals to x squared plus 4x plus 8. So we are asked to express this in vertex form and also to plot the graph. We are not going to use table method because we have to use transformation method, and because the first thing is to actually express this in standard form or vertex form. Okay, so to express a quadratic function in standard form or vertex form, and the only method you can use is completing the square method. Okay guys, before I continue this part, let me just quickly show you what we are trying to achieve here. So now when we end up with a graph like this, and the properties now, if you look at this now, where this quadratic graph cuts the x-axis, that's the root of the equation, or the x-intercept. Okay, also where the graph cuts the y-axis is the y-intercept. So we are trying to determine, or we are trying to define the properties of the graph. Then where the graph the origin of the graph is the vertex. Okay, let me just explain something so that when I'm working on the question, okay, print screen is not working here. Okay, then a line that horizontal, it could be horizontal, it could be vertical, depending on the nature of the graph, that runs through the graph and divide the graph into two equal parts is the axis of symmetry, and it has a coordinate here. Okay, so let's go ahead and complete the question now, so that we are expecting to have to have a final solution in that form. Okay, so that's the expectation. Okay, so let's just get started now. So I'm going to use completing the square method to express this in vertex form, or better still in standard form. So to do that now, and this is what you just do. Let me just go home now. At this stage, let me just quickly pause the video because of that distraction. Sorry about that. Okay, sorry guys, let's just continue. Okay, so let me take my pen now. So I have x squared plus 4x. So don't forget that completing the square method, we have to separate the variable and the constant. And this is an equation. You just write x squared plus 4x plus 8 equals to 0. So then if I move 8 there, then that will be minus 8. What I mean is I have x squared plus 4x plus 8 equals to 0. That's the equation. So when you move 8 here, you have minus 8. So this gives me minus 8. That's how you separate the constant and the variable. Don't forget completing the square method. So the next step is to find half of the coefficient of x. Coefficient of x here is plus 4. Okay, and half of plus 4 is plus 2. So we now have x plus 2. And then you open brackets and close square. So on the right hand side, you have minus 8 before. So to complete this square now, don't forget I told you earlier that irrespective of the operator that is here, that you add. Okay, so square of 2 is 4. Okay guys, unlike when you want to solve using completing the square, for standard form, to express quadratic function in standard form, you just bring everything to the left hand side and equate it to 0. So the final form I'm going to end up with now is x plus 2, then open your bracket and square. Okay, so this is minus 8. Minus 8 plus 4 will give me minus 4. So when you move minus 4 back here, that will give you plus 4. So that is the solution to the first one. So this is the standard form. So but generally the standard form is of this form. Generally standard form is of this form. Let me just write it here because I'm going to compare a into, and generally don't forget quadratic general form too. This general form is as squared plus bx plus c. That's general quadratic form. Also the general standard form of a quadratic function is what I want to show you now. So a into x minus h all square, then plus k. And from there also we have the vertex. The vertex is giving us is the where the graph is started from, h comma k. So meaning that I need to find the value of h and k. Okay, so if you compare this general form to the answer we have here, so minus h equals to plus 2. Implication h equals to minus 2. So you see that h equals to minus 2. So our vertex will be something like h instead of h. Now I can write minus 2. So minus 2. Then comma. The k, if you compare, plus k equals to plus 4. So the vertex is actually a minus 2 comma 4. So I can write this now. The vertex is minus 2 comma 4. Now apart from that, now look at this question. It asks us maximum or minimum. So don't forget that if you have a parabola, when your parabola open up like this, it is a positive graph, and this is positive. That is your a value, this a here should be positive. But if your graph open downward like this, then a is negative. It's also a negative graph. But if you look at our standard form, we have a is 1 here. If you compare this, a is 1. So since a is 1 and it's positive, so this is a minimum point, because a positive graph have a minimum point starting from this vertex and move up like that. But when it is a negative graph, you have a maximum point starting from the vertex and the graph move down like that. Okay, so this is a minimum point. So the first value here, or h, is always called the minimum point, and the second value is always called the minimum value. So you have the minimum point and minimum value, because if you substitute the point into the original equation, then you get the value. Okay, for example, if you find the root of this equation now, so the root of the equation, maybe you find there, you get a value, something like that. So now x-intercept is where the graph cut the x-axis, and y-intercept is where the graph cut the y-axis. So before we can do that now, so now let's now learn the real how to use transformation to complete quadratic function graph. So no, we don't want to use table, we want to use transformation method, and that's a very good one. Okay, so now let's get started now. Now, before you can use transformation to complete quadratic function, you need to let me quickly call your attention to something. Yeah, keynotes. Okay, generally don't forget that this general quadratic function, but when you have a general quadratic function here, a cannot be equal to 0, because if a equals to 0, you end up with a linear function, but b can be 0 and c can be 0. Okay, so the parent function, when you have your domain here, you have your domain and you have the function here, f of x. So domain is set of value of x. Okay, you have your function here. So the parent function is general s squared. That's the parent function, s squared. Okay, so when x equals to 1, let me just go ahead with the normal thing. So when x equals to 1, so 1 squared will give you 1. When x equals to 2, 2 squared will give you 4. When x equals to 3, 3 squared will give you 9, and so on and so forth. So let's see the application of this concept now. So now the vertex is minus 2, 4. So I'll go to minus 2 on x-axis. This is my x-axis, and this is my y-axis. So this is 2 here, this is minus 2 here, and this is 0 here. So x is minus 2, y equals to 4. So 0, 1, 2, 3, 4. So this is 4 here. So minus 2, 4. So this minus 2, 4 here. So and this is the vertex. So that's the vertex. Let me just use laser so that in order to show you. So see, it's blinking. So that is the vertex. So that is the starting point, and the vertex is what? Minus 2, 4. So minus 2, 4. So minus 2, 4. That is the vertex. Don't forget, guys. Okay, so that's how we're going to start. Okay, now, so I'm not going to, don't forget this formula, x plus 2 squared plus 4. Okay, so let's just get started with graph now. So the implication means that if you, normally if you remember in transformation, your gradient gradient is in linear function is changing y over changing x. Okay, and your x move to either to left or to the right, y move up or down. Okay, so 1 means that 1 step to the right and 1 step up. 2 here, 2 step to the right and 4 step up. 3 step to the right and 9 step up, something like that. So from the vertex, so this is the vertex now. So 1 step to the right, then 1 step up, then end here. Then from the vertex again, do it to the other side. 1 step to the left, like that, just like a mirror of it. Transformation. So 1 step to the other end and 1 step up too. So that's the first. Then come down to the vertex now. So 2 to 4 now. 2 step to the right and 4 step up. 1, 2, 3, 4. And you do the same thing to the other end to mirror it. 1, 2, 2 step to the left, then 4 step up, we end here. And you can continue like that. So that's how the graph will be. So I'm through with the graph already. So let me just join this. I don't have a curve kind of. I think I can still work with this. So this is the graph, and this is the graph. Okay, so that's a cool one. So that's the graph. That's a very nice one. Okay, so let's confirm if our graph is actually correct. Now this is minus 2 here. So to the left hand side of minus 2, that is minus 3. To the right hand side of minus 2, that will be minus 1. So if this is minus 2 here, minus 2, if you put minus 2 into the original equation, it gives you what? Minus 2 plus 2, that's 0. 0 squared is 0 plus 4. You see now minus 2, 4 is correct. Then when x is minus 3, minus 3, based on the graph I have here, minus 3 gives me what? 5. 0, 1, 2, 3, 4, 5. If you look at this now, this is minus 3. This is 0, minus 1, minus 2, minus 3. Then 1, 2, 3, 4, 5. So mean that minus 3 should give me 5. So let's confirm. If I put minus 3 here, minus 3 plus 2, that's minus 1. Minus 1 square is 1. That's 5. Do you see it's correct? So that's, you can just confirm that. So our graph is perfect and correct. It works for we're going to take a look at more question anyway in maybe other series of this for this tutorial class. Okay, so that's good. So x-intercept is where the graph called the x-axis, and if you observant, I showed you something before now. So this graph did not cut x-axis anywhere, so this has it has no real roots, so no x, so that is none, no x-intercept. Okay, then y-intercept is where it cuts the y-axis, so 0 1 2 3 4 5 6 7 8. Let me confirm. 1 2 3 4 5 6 7 8. So y-intercept, is always generally is 0 comma y, because it's when x equals to 0, so meaning that 0 comma 8. So because it cuts the y-axis here, 8, this is 8, value here is 8 if you label it. Okay, let's confirm that. If I put 0 here, when x equals to 0, so 0 plus 2, that is 2, 2 square is 4, 4 plus 4 is 8. Do you see that our graph is perfect? Okay, so axis of symmetry. So axis of symmetry is a line that runs through the graph and divide the graph into two equal half. So let me just run a line through from here. So an axis of symmetry will always pass through the vertex. It will always pass through the vertex. So, and where the graph cut the x-axis, so sorry, where it's cut this x-axis, do you see now? So it's cut it at -2. So the axis of symmetry is more like h, so that's -2. So axis of symmetry is -2. So axis of symmetry is -2. Then the domain, the possible value of x, okay, all giving possible value of x, so set, so it's a set of x values. So, and if you look at this graph now, if I keep plugging, I can put x equals to, from here now we have -2, so -2 to the left hand side, that will be -3, -4, -5, -6. Let me just use this to indicate what I'm trying to show. So this is -2 here now, so it could be -3 here and we get this. It will be -4 to get this, -5 you get something very big, -6. So it means that it will continue to tend toward this end, toward the negative side of x. So, and it's continuing indefinitely, so it's infinite set, so infinite number rather, so that will be -infinity. Also, this is -2 for x here, so x could be -1, 1. So when it is -1, you see the value. When it is 1, you see the value, and when it is 2, you see the value, like that. So it continues, so it also tends toward positives. Sorry about that. Let me just use this. So it also tends toward the positive side of the x-axis, and it's continuing indefinitely. So also that will also be to +infinity. So meaning that the domain can be any real number. Do you understand? So it belongs to, so it's an infinite set, any real number. So domain, let me just write it as d of x. So domain, so I want to write it as a function. It's a function, okay, such that let me just write it like that. Okay, so it's an open set anyway, -infinity, don't let me waste my time, to +infinity, such that x belongs to a real number. Can I write that one here? Such that x belongs to a real number. So any possible value. Okay, so and the range too. So let's take a look at the range and the vertex. So let me just quickly maybe just a quick one. This is the vertex here, this point here, 2, -4. This is I just want to draw this line. So, and if you look at the vertex, this graph actually the starting point here is 4 on y-axis, so there is nothing below 4, so the starting point is 4, and from 4 now from 4 you can go 4 5 6 7, and it tends up here. Let me just take this now. So the starting point is 4, so from 4 then it continues indefinitely to the positive side of y-axis. So don't let me use this one to destroy my graph. I think it's okay. Okay, so just it tends up like that, and if you look at below 4 you have negative of y, but above 4 is positive, so mean that the starting point is 4, so it has no value below 4. So and it has a big the beginning, the starting point is 4. So since the starting point is a closed set, so it's a closed set. So 4, from 4, then comma, then it goes to plus infinity because it moves up indefinitely. So that's an open set. So and that's that. Okay guys, hope you understand. If you don't understand, you can pause and rewind, and play the video also. So let me quickly go ahead with the last question. So let's just go ahead with the last question. So I can take this one off now. So let me import the last question to call off the tutorial class. So guys, this last question now is just like this. Is similar to question 1, but I think there's something about that. Let's just take a look at it. Okay guys, so unlike if before now, the type of completing the square function if you're working with is such that the coefficient of x square is 1, but if you look at the coefficient of x square here is 3, so that's why I consider this a very good one. So let's quickly learn how to complete this. What about how to complete the square if the coefficient coefficient of x square is not 1? So that's why I like this question. Okay, so let's get started now. Okay, so the first thing, don't forget the first is to separate the variable and the, because I want to express in standard form, vertex form. So so I'm going to separate the variable and the constant. So I can just start that this question actually equals to 0. Okay, now guys, before you can do this, before you can use completing the square method, step 1 is not actually separating the constant and the variable. You have to make sure that the coefficient of x square is 1. Coefficient of x square must be 1. So since the coefficient of x square is 3, then I'm going to factor out. So that's the step 1. I'm going to factor out. So 3 is common. So I will start by writing 3, then open a bracket now. So x square, then 3 in 18, that's minus 6 x, and finally 3 in 15, that's plus 5. Okay, now so what I have in brackets now, I can now start the step 2 now, that is separate the constant and variable. So this 3, I'm going to keep it, and since I need to keep it now, let me just put it in square box or whatever. It's just quadrilateral box. It needs not to be square, so it is just a box, whether square or rectangle. I don't care about that, guys. So now what I'm going to complete the square of for this function, x squared minus 6x plus 5. So I'll just ignore this 3. So let me work with this one now. So let's continue with this step now. So we separate the constant and the variable now. So I have x squared minus 6x. Okay, so and this is plus 5 here, plus 5 move to that side, that will be minus 5, equals to minus 5. So the next step is that we take half of the coefficient of x. So half of coefficient of x is let me just work here, and that's minus 3. So that x minus 3, then all square, x minus 3 all square equals to minus 5. Guys, don't forget, before now I already told you that irrespective of the operator that is here, you always add the square. So so minus 3 square, that is 9, so that's plus 9. Okay, so that's also the standard form will now be is of this form now. So don't forget that I put this thing away. Okay, before I write this, let me just let me complete it here. So now I have so if I want to introduce this 3, now I'm going to have 3. Let me just write it down here. So I have 3, then open a bracket now. Let me open a big square bracket. So I can now write this one now, x minus 3 all square. Okay, then minus 5 plus 9, that is 4. If you move 4 here, it becomes minus 4. So minus 4. Okay, I can now close this one now. So don't forget the standard form now. The standard form is always such that you have this. So I'm going to use 3 to open up this one. So I can write the vertex form now. So that will be 3 into x minus 3 square. Because I want to write in vertex form. So I can use 3 to multiply this 4 now. So that's minus 12. So this is the vertex form. That's a good one. So guys, so don't forget how to complete the square when the coefficient of x square is not 1. So you have something like this. So I want to compare it with the the standard form of the quadratic function standard form. So that's compare with a, open a bracket now, x, just like the first question, minus h square, then plus k, and plus k. Okay, so don't forget that the vertex is such that the coordinate is h comma k, So what is h, and what is k? So if you compare this one, minus h equals to minus 3, a equals to 3. So you can see, let me just take this, you see now, so a equals to 3, h equals to minus h equals to minus 3, and k equals to minus 12. So you can write out the values like that. Okay, let me just complete the task now. So the vertex now, so let me just put the coordinate of the vertex here. So the vertex is minus h equals to minus 3, therefore h equals to 3. So 3 comma k equals to minus 12. So 3 comma minus 12. Okay, and if you, how do we determine if it is maximum or minimum? Look at value of a is plus 3. So since it's plus 3, then it is minimum. It is minimum. So mean that it's a positive graph. So let me sketch the graph now, because you can't determine the remaining solution without the graph. Okay, so let's sketch the graph now. So this one said I should go to 3 on x-axis and minus 12 on y-axis. So 3 on x-axis, this is 0 here. This is 1, 2, 3. So this is 3 on x-axis. But if you look at this grid, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can't have 12. So by implication, I'm going to use 2 units represent a square box. So such that I have, this is minus 2, minus 4, minus 6, minus 8, minus 10. Am I correct? Minus 2, minus 4, minus 6, minus 8. 2, 4, 6, 8, 10, minus 12. Okay, so I need minus 12 now. So this is minus 12 here. So 3 minus 12. So this will be my vertex now. So it's starting from here. So let me just take this line. I think I like to use this. So this is the vertex now. This is the starting point. The starting point here. So this is the vertex. So don't forget I use 2 units to represent the square box on y-axis, but the square unit to represent the square box on x-axis. Okay, so the vertex now. So that's the vertex. So vertex is that is 3 comma minus 12. So that's where I'm going to plot from. So we also consider the parent function. Don't forget, but I don't need to draw that again. The parent function is all x squared, such that we use the transformation. So let me just quickly do that. So can you come up? Can I do that? Okay, so don't forget the parent function, but this time around I will just need to, it's a little bit you just need to be careful. S square, and you have for the function, so you have x. So this is f of x, don't forget. So f of x is such that, so when x equals to 1, I have 1, and when x equals to 2, I have 4. That's what I should have. But the problem with this one is that because of the coefficient of x here is 3. So see what I'm going to do now. Okay, so let's just get started. 1 is not a bad deal. We can still, that's a good one. So now the vertex is 3 minus 12. Okay, so this is 3 now. So and we have the standard form already, 3 into x minus 3 square minus 12. So let's just plug in. I think I need my calculator this time around. Let's just come to 2. I need to do this now so that I don't get into trouble. Can you bring it out? Okay, thank you. So this calculator, let me put it here because I don't need that table again. Okay, so now this is 3 here. So let's confirm this first. When x equals to 3, what is y? So look at this now. 3 minus 3 is 0. 0 square, 0 times 3 minus 12, and it's correct. 3 minus 12. Okay, so now, so what you just do is that to the left hand side of 3, that will be 2. Okay, that will be 2. And then to the right hand side of 3, and that will be 1. So just plug in now. So let's start with when x is when x equals to 2. So what is y? So let's come here now. So when x equals to 2, 2 minus 3. that is minus 1. Minus 1 square is 1. Okay, so 1 times 3 is 3. So 3 minus 12. 3 minus 12. Let me bring out the calculator. I think I'm going to, I'll just use my mental. Okay, I think it's a very simple thing to do. I don't need to use this calculator, guys. It's giving me trouble. Okay, just come here, guys. Okay, so now let's do it again now. So when we have this is 3 here, 3, so we want to check when it is 2. So 2 minus 1 minus 1. Okay, minus 1 square 1. So 3 times 1 is 3. So 3 minus 12. 3 minus 12. So 3 minus 12, that is minus 9. So mean that we should get minus 9. So 2 against minus 9. So we should have 2 against minus 9. Okay, and don't forget this is minus 12. This vertex, this is minus 12 here. This is minus 12 here. This is minus 10. Okay, this is minus 10. This is minus 8 here. So minus 9 is in between. So 2 minus 9. So this is minus 9 here. Okay, so this is 3. So this is 2 against minus 9. So also we can check 1 also. So if we confirm 1, definitely it's going to give you minus 9. You can confirm that it's going to give you minus 9. I know that one, but so let's just confirm anyway. So when it is 1, I have 1 minus 2. 1 minus 2 is minus 2. Minus 2 square. What am I doing? This is 3. Don't mind me. 3 to 2. Okay, so to the right hand side is 4 now. What am I doing? So when this is 3, to the left hand side is 2. 3 to the right hand side is 4. So when it is 4, sorry. So 4 minus 3. 4 minus 3 is 1. 1 square is 1. 3 times 1 is 3. 3 minus 12 is 3 minus 12 is minus 9. So I'm correct, minus 9. Let's quickly check one more. So this is 3. Right, so 3 here. So when x equals to 3, then when x equals to 2, then let's check when x equals to 1 now. So when x equals to 1, so when x equals to 1, I have 1 minus 3, that's minus 2. Minus 2 square, that is 4. 4 times 3 is 12. 12 minus 12 is 0. Okay, let me confirm that again. This is I have 3 here, 2, 1. So when x is 1, I have when x is 1, y is 0. So mean that it's going to be here. I'm going to confirm it again. When x equals to 1, y is 0. Okay, so this is 1 comma 0 because this is 0 1. So when x equals to 1, y is 0. But let me confirm that again. So when x equals to 1, so 1 minus 3. 1 minus 3 is minus 2. Minus 2 square is 4. 3 times 4 is 12. So it's 0. So definitely this is 3 here. 3. This is 3 here. 2. 1. Sorry. 3, 2, 1. Yeah. So we check when it's 1. So to the right is increasing. So 3, 4, 5. So we are going to check when it is 5. So when it is 5, it should give me the same answer here. When it is 5, it should give me the same answer here. So let's see. When it's 5, it should give me 0. Let me just confirm. So when x is 5, when x equals 5, so 5 minus 2. 5 minus 2, that is 2. 2 square is 4. 3 times 4 is, so it's correct. Guys, at this point, I don't want to. Let me just. I have my graph already, guys. Okay, we've not. Okay, need to cut y-axis because I cut x-axis. Still one more because I have not cut y-axis. Okay, so guys, 3 to 2 to 1 to 0 now. Don't forget this is 3, 2, 1, 0. So when s equals to 0 now. So when s equals to 0, I'm going to have minus 3 squared. That is 9. So 9 times 3 is 27. 27 minus 12. 27 minus 12. That is 15. So when s equals to 0, y is 15. So 15. So let's count now. This is don't forget that y is 2 units. So 0, 2, 4, 6, 8, 10, 12, 14, 16. So this is 16. So 15 will be here in the middle. Let me confirm again. 2, 4, 6, 8, 10, 12, 14, 16 up, so 15 is here. So definitely also that's when it is 0. So let's count here, because we move from 3 to 2 to 1 to 0. So how many? 1, 2, 3, 3 backward. So sorry, so 3 minus 3, so add 3 also, 6, so that again 6. So 4, 5, 6. So when it is 6 also, when it is 6, it should correspond to that side. When it's 6, it should be here. So it should be 15 too. Let's confirm. When it is 6, our answer should be 15. Y should be 15. So let's confirm. So when it is 6, I have 6 minus 3, and that is 3. 3 square. 3 square is 9. 9 times 3, 27. 27 minus 12 is 15. So it's correct. So I'm cool now. I can complete my graph now, guys. This not this this not it's not car. This is quite cool, like. So guys, that's it, guys. So just join this to this, join this to this, join this to, I have to be smart guy. So that's the graph there. So join this to this, guys, join this to this, then it goes up like this. Let me just take it from here, so that will be quite cool. Can I undo that? Okay, so just need to be, I don't have curve on this app. I don't know why it's curve. It should have been easy. So it's freehand, guys, and in your normal exam is also freehand, so maybe that's why my app is it's very difficult to plot. Just bring it down now. Can I do that again? No. What's going on? Don't do that for me. Just skip it, guys. Let me just continue. Cut. Okay, let me just let me quickly let me pause the video, because if I should close this program, I'm going to lose track of everything. Let me just take light shots so that I can have this page here. So let me just take this print screen now. Will you work for me? Okay, I need to save this. Maybe I should just pause the video, and because I can't debug now, so I just need to complete this graph, guys. You just complete this graph here. So because I'm rounding up already, let me just quickly take a look at the next. Can I just click so if you look at this now, the x-intercept, the best thing is for me to just pause the video. Let me just pause it. Let me just. So guys, sorry about that. My board just misbehaved. So let me just continue. So sorry about that. Okay, so you can see now, you plug in when x equals to, we have the vertices already, 3 minus 12. So to the left hand of 3, that is 2. So when x equals to 2, just plug in 2 into this equation, then you get y. You see that when x equals to 2, 2 minus 3 squared minus 2, that will give you minus 9. Okay, then when x equals to 1, so plug in 1 minus 3 minus 12. So you have all these coordinates, and we complete the graph like that. Okay, so the x intercept is where the graph cuts the x-axis, and if you look at this, where the graph cuts the x-axis, that is 3, 2, 1. So that is s equals to, there are 2 values there. So here we have x is 1 here, and 1, and y is 0 there, y comma 0. And can I say union? Let's say union. And if you have here, it's got it 5 here, so that's 5 comma 0. So you better still, you can just write them s equals to, because this is not set, guys. What's this? And I write my 0 like that, guys. Okay, so 5 comma 0 is just too big. So and this is not it's a set, is okay like this, or if you just want to write it in quadratic form, so x equals to 1 or x equals to 5, like you have root of equation x equals to 1, which is the conventional form, or x equals to 5. So x equals to 1 or 5, so that's the root of the equation. If you have to solve this, that will be you put 1, it should satisfy, and if you should put 5, it should satisfy the equation. That is 1, when you put 1 in this equation, to be equal to 0, and when you put 5 there, you also write it like this. So y-intercept is where the graph called the y-axis, and I call the y-axis when x equals to 0, that is 15. So when x equals to 0, 15. So the y-intercept is always written as x comma y. What am I writing again? So x comma y, general form. Okay, sorry, since it's y-intercept, so x is 0, I'm correct. So 0 comma y. So and what is that? So that's 0 comma 15. So I don't need to write that. I don't know why I'm trying to take my time explaining everything. So I think you guys understand. Okay, so this will be y-intercept is 0 comma 15. That is where the graph cuts the y-axis, 0 comma 15. Don't forget that from the first question, the axis of symmetry is h. So I don't need to waste my time there. Axis of symmetry is h, and h is 3. So that is 3. But I can confirm that, guys. Let's just do it. So because of our time is fast spent. So just axis of symmetry is a line that runs through and the graph and divide the graph into 2 equal parts. So where it's called the x-axis, that is 3. That is the axis of symmetry. Okay, so you want me to write that? Say yours. Okay, so this line is axis of symmetry and its x value. Axis of symmetry. So you sometimes see it as AOS. AOS, that's axis of symmetry. Okay, we need the first domain. So just like I explained earlier on, so we keep on this 3, so 3 extend to minus to 2 to 1 like that indefinitely. So it's tend toward negative infinity, and from 3 the graph also widen towards that place to positive infinity. So the domain d of x is a set, so such that if x belongs to R, so it's a set of all real numbers, okay, such that so and is an open set, minus infinity to plus infinity. I don't even need to write all those, just minus infinity to plus infinity is okay. So the range, and so this we will take this line now. Let me just use this. So this is the vertex here. So from minus 12 upward, so from minus 12 to positive and to positive infinity, because it extends minus 12 and it's continuing indefinitely. So the range 2, so I can write that one as r of y, because the y value, so range, okay, such that if y also belongs to all real number, okay, all real number, such that so it's a closed set because that's the starting point and it's closed, minus 12. So from minus 12, then it goes up and extend like that to plus infinity. So guys, hope you this open, this is closed, square brackets. So guys, hope you enjoy my tutorial class. Thank you very much, and do have a great day ahead. Please do well and subscribe to my channel. So bye bye guys, bye guys.